So yeah, for the next few minutes, I'm going to talk about the platform, and then Patrick is going to do a demo, and we'll wrap up with a little Q&A session for all your questions regarding the product. So what is the platform, and why did we build it? And there's three main motivations for us to build this product. The first motivation is the need for streaming platforms. The second motivation is that companies that are getting started with stream processing need the right tools from day one. They don't want to spend all their time with messing with the infrastructure. And the third motivation is that people need tools to operate stateful streaming applications on top of stateless container managers or resource managers. So looking at the first motivation, we've been working with a lot of early adopters of Apache Flink on building their internal streaming platforms. So usually the story goes like this, that first a team starts out doing some use cases with Flink, and they do all the hard work with the infrastructure integration, like all the internal logging system, metric systems, the storage system, state access, data access like Kafka sources, file systems, security requirements, and potentially also auditing requirements. And then as other teams also want to do streaming, there's a need for some kind of platform so that it's easier for other teams to adopt and don't go through all the integration work again. So you basically integrate once with an organization, and then you scale adoption and you grow adoption. And also these companies want their engineers to focus on use cases instead of the infrastructure. And also many companies are developing agile methodologies where they allow engineers to control themselves what they deploy and when they deploy it, and also that on commit you automatically upgrade your job on a staging system to validate that it's correct. So this is one motivation for building streaming platforms. The second motivation is that companies that are just getting started with stream processing want to benefit from these lessons that these early adopters of Flink have learned. And that's why the platform is also a great tool if you're just getting started with stream processing and you're looking for the right tools. So instead of spending your time with all the moving parts like logging, metrics, state storage, and so on, you actually spend your time focusing on your use case, solving your business problem. So that's the second value proposition of the platform. And the third one is about operating a stateful stream processor on top of Kubernetes or in the world of containers. So containers are generally stateless. So in traditional applications, you have like a central database that you're using for keeping your user records or the information of your application. But with a stateful stream processor, you want to actually have a tool that allows you to manage the compute and the state together. And that is the third motivation of the platform. It basically adds stateful stream processing awareness on top of Kubernetes or other resource managers. So to summarize the motivation, the first one is easy integration and focus on use cases for organizations. The second motivation is that companies want to have the right tools from day one. And the third motivation is that people want to operate a stateful stream processor more easily on top of stateless containers or on top of their resource manager. So digging a little bit deeper, how did we solve this problem? So how does the platform work? One main idea that we have is that the platform provides declarative control of deployments. So you don't have like RPC call, submit a job, and then you have an RPC call, cancel the job. What you rather have is a specification of a deployment. So you define, this is the jar that I want to run, this is the parallelism that I want to run, these are the resources that I would like to use for this is the Flink configuration. And then you give this to the platform and it takes care of running it as you've specified it. If something goes wrong, the platform will recover from this failure for you. And you're also getting back from the platform status reports, you're getting an event log. It integrates with the logging and metric system, so you're also getting the log messages from Flink. So this is one benefit of a declarative control. Another very interesting benefit is that it actually makes it quite easy to integrate with other systems. So for example, if you want to build a CI/CD pipeline that triggers upgrades of a job automatically, then it's very easy to just change the specification from the CI system, and the platform will translate this into an operation on Kubernetes or into an RPC call to Flink. So if I now change the specification of this example deployment from running to cancelled, the platform will take care of deallocating the resources on the cluster. This is actually getting even more interesting if you're changing the parallelism. So in this example, I'm scaling up my Flink cluster from 60 to 80 machines. And as you see in this graphic, basically the platform again takes care of allocating the additional resources for you. But it's getting really interesting if you're also taking the state into account, because as I've said, one of the motivations for building the platform is that it's a stateful aware resource manager, basically. And it does not only scale up the cluster, it also migrates the state of the old cluster to the new cluster. What this means is that, for example, your data that is in flight in a session window or running aggregations from a window are migrated to the bigger cluster, and you can continue with the processing without any semantic data loss. This stateful awareness actually allows or enables a very large variety of very interesting use cases. So it allows you, for example, to upgrade your Flink job. So if you detected a bug in your application and you want to fix it, you just tell the platform in the definition of your deployment that you would like now to run this other jar, and the platform will take care of upgrading your Flink cluster to now run this jar, and it will also take the code, the state to the new Flink job. Similarly, you can upgrade between Flink versions. You can change your parallelism. You can change the resource allocations, configuration parameters, and it also allows you to suspend and resume a deployment. So if you want to deallocate your resources without losing your current computation, you just press the suspend button in the UI, and it will basically pause and deallocate your resources. What it also allows is that you can basically version your application, your code, and your state alongside. So the platform keeps track of all the state, of all the save points that you're creating, and of all the jars that you've submitted, and also the configurations that you've used. So whenever you're upgrading a job, it keeps track of the older version. So you can always go back if you find that there's an issue, or if you would like to understand how a certain change affects the performance, for example. And there's actually more interesting scenarios that you can build. You can also fork an application and run a job with, let's say, a different parameter. So if you're running a certain, let's say, machine learning model, and you would like to try different parameters, you can also fork a currently running application and try it out with different parameters using the same state. So you see what is the outcome of this different parameter based on the same input. So you can basically do something like A/B testing very easily with a platform and its declarative definition of deployments. And of course, you can also upgrade the forked version and build whatever scenario you'd like. So the next question is, how did we implement this? Or what do you get as part of the DIA platform? And the architecture looks like this. So everything is based on Kubernetes. All the components are Docker images. The main component of DIA platform is called Application Manager. That's the component that exposes a REST API for creating these deployment specifications. And Application Manager also then talks to Flink and Kubernetes for allocating resources. So as I've said, all the components are provided as Docker containers by Data Artisans. We are also providing an installer tool for setting up the platform. And as part of the platform, we also ship a DA distribution of Flink that has minor patches on top for improved compatibility with Application Manager, but the version of Flink that we are shipping is fully compatible with the open source version of Flink. We are also providing components for metrics and logging. This is mostly for demonstration purposes or for companies that are just getting started with stream processing and that would like to use the right tools from day one. We advise companies to rely on their existing metrics and logging solution, and we provide the integration points as part of the platform for actually doing that. Because it makes more sense to have one unified organization-wide metric system, for example, so that you see the hardware metrics correlated with the metrics from your stream processor. Going a little bit into Application Manager. So as I've said, it communicates with the outside world through a REST API. We also provide a JavaScript-based web interface for interactively controlling Application Manager. But the REST API is really a first-class citizen of Application Manager. So we provide a Swagger spec. You can just use the Swagger client if you want. And you can directly talk to the REST API for building CI/CD integrations or integrate it with your internal deployment system or your internal systems as you wish. Application Manager is also obviously talking to Kubernetes or Kubernetes distributions like Red Hat OpenShift for allocating Flink clusters. And once Kubernetes has started a Flink cluster, it will talk to Flink directly to submit a job or to control a job, to trigger save points, to cancel jobs, to monitor the job status, and so on. And also Application Manager is keeping track of all the changes and of all the save points and of all the metadata basically that is accumulating over the course of deployment changes or Flink status changes, so that you can basically keep track of everything that has happened. And I've mentioned it already, one very nice use case that we see with DIA platform is the hooks for CI/CD pipelines that we provide. So the idea is that as soon as the developer is pushing an update to the version control, the CI server gets triggered and it builds the latest version of your streaming job. Then the CI system talks to Application Manager, and that's actually really easy, just a patch call on the REST API where you update the location of the jar to the latest build from the CI server, and then Application Manager will perform an update of the application. And that's actually a very nice scenario for automatically building like a CI/CD pipeline with Application Manager. And with that, I'm going to hand over to Patrick to actually show you how DIA platform looks in action.
Cool. Thanks, Robert. Need to switch over to this real quick. So if you attended the keynote this morning, some of this is going to look familiar. Awesome, here we go. First I'm going to walk around the actual user interface for Application Manager here, if you're not familiar with it. I also want to go in and say that this is, we have a trial version now available on our website, So definitely go check it out after the conference. There's a demo VM and also some scripts to let you deploy it onto your own Kubernetes clusters. So this is your overview page of Application Manager. Fairly self-explanatory. These are the deployments that Application Manager is handling. So clicking down into one of these, there we go. This is kind of the overview. That's your entry point to everything about one of these deployments. You get your current status and as well as the desired status. All of this is being fed from the REST API, so you can get all this information yourself to work with your tooling. In this particular job, I'll come to kind of what it's trying to do in a short while, but you can see that it has a certain amount of allocated resources, and these are translated into limits and requests in Kubernetes. Additionally, Application Manager will track events associated with a deployment. This is your starting point to kind of figure out how it got to the state it's currently in as it's trying to allocate resources, when it's tearing things down, taking save points, and so forth. Similar story here, the history of jobs for this application. I want to come back also to a key point here that Application Manager, the reason it's Application Manager, is because Flink itself doesn't have a concept of a long-lived application. That is, as soon as you want to upgrade your job to a new code, your Flink application, that job goes away. It's gone. You can get some history out of if your Flink cluster is long running, but there's not really anything that would tie one to another. So the application concept in Application Manager is what does this, what brings it together. So these jobs listed here were instances of an actual Flink job, and that's why we kept the naming there. For any job or for the application as a whole, you can also take a look at its logs using the included kind of demonstration ELK stack to help with debugging. Additionally, Application Manager is tracking the save points, both the ones created automatically when you choose to suspend the application, but also you can manually request that a save point be created, and Application Manager takes care of talking to Flink's APIs to ensure that happens, and then keeps track of it here so that you can reference it later. So, kind of going on to the real part of the demo. This was also what you saw earlier, similar visualization, and what we're trying to evoke here is payments happening on some platform throughout Europe. And this is what it should look like when everything's working great. This is a 3-day view. We have some just basic visualization on a map to see the relative magnitudes of how many payments we're seeing. But we got some kind of alert, something's gone wrong, and this would be our first stop to try to figure out what it is. So indeed, there should be a nice red dot right here on Germany, as according to this view. It's not there, and indeed, if we look down here, something happened right around here. Don't know what, stopped receiving data, stopped emitting data, something went wrong. And I'm going to leave out the part here where we fix the bug. I think you can use your imagination. Someone identifies what's wrong. This is really to do with your application code. You could look in the Flink logs. Maybe there's something there, metrics. Nevertheless, we solved the problem, and we've produced a new jar, a Flink jar that we can use. And so we don't want to touch our production deployment. We want to be careful here. So we can start with a staging instance of this application. This is actually the exact same code as production, just with a slightly different configuration. In this case, the results are being written to Elasticsearch. The staging job consumes from the same source, but is writing to a different set of indices in Elasticsearch. So let's try out our new code on this application, this deployment, sorry. These are all the things, almost all the things that you can configure about an application. I'm not going to go through them here, but once again, all of this is just an expression of the same resource that you can manipulate with the API. In this case, I'm going to change the jar that we are deploying to one that doesn't have the unfortunate bug. And when I apply this change, Application Manager will coordinate an upgrade. So this means effectively taking a save point and then replacing the cluster and deploying the new job. We're already halfway there. The old cluster's been torn down, and it's waiting for the new one to start up. Meanwhile, if we go over to the close-in view of our data here on the staging index, hopefully what we see soon is that the values for Germany that are currently down at 0 pop up back up to the levels we expect. There they are. So everything looks good. We want to promote this now to our production environment, get things working as soon as possible. So now what I'm going to do, and you can also imagine that this process is coordinated through a CI/CD system. So initially, as soon as the new code is ready, that artifact is built, it automatically upgrades the staging environment, and then when you're happy with the results, you hit a button and it does the same thing for the production deployment here. So I'm going to repeat this process with the production deployment now. Once again, took a save point. It's tearing down the cluster and is going to replace those resources. The save point it just took, you can see here. It's very quick, not very much state. And now the new resources are coming online. Going back to our view of the live production dashboard, we should similarly start to see an uptick over here on the far right of our graph once the new data starts coming in. Boom, there it is. Nice red dot here. And then this will take a few minutes to come back up just because of Kibana aggregating that data. So this is all well and good. It seems like things are back to normal, but we do still have this ugly gap of wrong data in our dashboard here, and it'd be nice to fix that up. Now, like in the keynote earlier, when Stefan gave that demo, he reset to a save point that from before the bug was introduced. A good practice would be taking save points periodically, for instance, nightly, so that you always have this option to replay your data. But in our case, I wanted to show something slightly different. Another option here is we can let this application continue to run, producing the correct results. And meanwhile, we're going to fork the application, resetting it to the earlier save point with the corrected code, and let it backfill our data. So first of all, this is the production deployment, and I'm looking at these save points. And I happen to know that this earliest user-requested save point fits our bill here. So I'm going to, instead of not reset here, but I'm going to fork. It starts off canceled, but it's all ready to go. It's identical to the other deployment in every way, except that we have copied over this pointer to a save point. It's not actually copying the save point data in your archive, just the pointer. And to make things a little easier, I'll make a note here that this is helping us with a backfill. Please don't delete. Save that, and I'm going to kick it off. So this is bringing up another Flink job alongside both the existing staging and production deployments, and restoring from that earlier save point. And what we're hoping for is to see our data get corrected on the production dashboard. This is now running. Meanwhile, I'll show you, of course, you can proxy through to the Flink user interface and see the job running. All your usual, it is, as you expect, real Flink underneath, nothing special there. If I go back to this dashboard, I was a little too late. The data is getting backfilled. And so your process here would be, once all the data has been corrected, we can tear down this deployment and delete it. I'll leave that to your imagination for now. I did want to show one other thing, which is that the API for Application Manager is specified with OpenAPI or Swagger, and we bundle along with the web application the Swagger user interface, and this helps with kind of crafting your own HTTP calls to do all those same operations that I was just doing with the user interface. So, for example, I can go to the deployments part right here. This shows an example deployment resource, and actually even gives you a way to actually run these commands. Somehow you could actually use this as a alternate interface to Application Manager. Things look a little nicer. So this is you can get a deployment list back if you just do a GET request against the deployments endpoint. And here's my temporary backfilling deployment right here, just to check. Okay, we're good. All that data has been backfilled. And so I'm going to grab this ID, and I'm actually going to also use the Swagger interface here to delete that now unnecessary deployment. So, try it out. Ooh, deleting a running deployment is not allowed. So, of course, I could patch it here, setting the desired state from running to canceled, but instead, I'll just do that from the user interface. So, we don't actually care about any save point here, keeping the state, because now it's identical to the real one. I'm just going to cancel this, reclaim the resources. It's done. Go back over here. Success. So that deployment is now deleted. If we go back to the just a GET request here, now we're only left with our production and staging dashboard, payments dashboard deployments. I guess just one other quick thing is that many of these GET request endpoints also support label selectors. So in our case, we specify labels environment for staging or production, and I can go here and request, for instance, that we only get any deployments with the production label. Yeah, so I think that kind of covers the basics of Application Manager. Again, check out the website, the download page, and you can get a demo VM as well as a package that you can install a trial version of Application Manager and DA Platform on your Kubernetes environment. Yeah, thank you.
Thank you.
I think
So
that
I
was
have a few more.
Start, sorry. Yeah.
I have a few more slides. So as Patrick already said, the platform is available. So a bit of history first. It has been announced at our conference in Berlin in September in a closed beta program. We had 190 beta signups, and we've worked with some of those users to develop the product, get feedback, and make it like a great experience for these users. In March, we made the platform generally available, and as part of this GA, we also released a virtual machine, like a sandbox VM, that you can use for trying it out and for doing what Patrick just showed you yourself. And I recommend to use the sandbox first, and if you like the experience, then go ahead and download also the full Kubernetes version, so you can also deploy this on your own Kubernetes cluster, on your Red Hat OpenShift cluster, or on any cloud provider, and all the major cloud providers support Kubernetes, to try out their platform yourself. The DIA platform license includes enterprise support for everything in the platform, including Apache Flink. Looking a bit at the roadmap, the next big topic that we're going to tackle is improved access control, so that we introduce a concept of ownership for resources, or ownership for deployments, jobs created by deployments, save points created by deployments, and then access control based on this ownership. The second big thing that we are looking into is metadata management, so awareness for sources such as Kafka topics, files in S3, and HDFS, and then we're going to store schema information, event time fields, watermark extractors, and other relevant information, so that basically the platform can track for you how also the data between different job deployments, how this data relates to each other. Another big topic is SQL, so we want to make SQL a first-class citizen of the platform with interactive interfaces for submitting queries, and also integration points for existing SQL tools, so that you can access the results of your queries with BI tools and other tools. Another feature that is very interesting for our users is multi-data center failover. So if you want to run a Flink cluster in one data center and you want application manager and the platform to basically fail over to the other data center in case of a disaster in the first data center, and that's basically another feature that we have very high on our feature list. So with that, I would like to conclude, and thank you for your attention. And now Patrick and I are happy to take some questions.
Thanks. Two questions. First one is, when is this really going to be available, like for reals? And because right now it's just like a trial and there's no pricing on the website or anything.
This is really available. I mean, you can download the full Kubernetes version.
I mean, I'm running it in Kubernetes. My question is, when is this going to be like ready for production? Or like, I don't see pricing on the website, which tells me that this is kind of like beta and like not ready for production.
Yeah, so for pricing information, either come to our booth or contact us on our website.
Oh, okay.
Any more questions?
All right, it looks like there are no more questions. Thank you everybody for joining. And I think let's give a last round of applause to our...
Thanks.
Thank you.